Okay, so we're going to go over sine and cosine law. These are the two laws. Your sine law. Sine law is a set of ratios. Okay, sine A divided by side A is equal to sine angle B divided by side B, which is equal to sine angle C divided by side C. This can also be set up reversed, or I could have it saying A, B, and C on top. Whoops, not what I wanted. And the C on top. It's really annoying. The C on top, okay? So it could be C over sine C, B over sine B, or A over sine A. Either of those is fine. So we can flip this or start it with the angles on top, okay? With that being said, cosine law, I usually get the students to just remember the one set of formulas, and the letters are interchangeable. So for instance, the only thing you really need to know, if this is side C, you're either solving for this side C, or you're solving for this angle C. Those are the only two things you're going to focus on solving with cosine law. So if we're looking for side, or if we're looking for either angle C or side C, we make that the side and the angle at the end. If we were looking for A, well then this would become an A, and this would be angle A, and then these two would be C and B. Okay?
But how do you know which angle you're going to look
It completely depends on what the triangle is asking us. You can always rename a triangle anything you want. Okay? So, for instance, let's bring up a question. I'll try to make one. Do you want to flip over to the page that has...
I don't even know because we didn't work in this book for it.
Oh, okay. So let's just try to make up some questions as we go through here. So, for instance, we'll get a triangle out. Okay. And let's say I have 50 degrees. This is 20 meters, and this is 30 meters. Okay. That means 3 parts of a triangle are unknown. To work with either of these, we need at least 3 parts of a triangle. Less than that doesn't really give us enough information. We can't work with it. So we need to have at least 3 pieces of information. There are a total of 6 in terms of what we're talking about. You always have your 3 angles, and you have your 3 sides. Those usually mean that they're the same length, but they're not. I'm just pointing out the 3 sides. Okay. So there's 6 pieces of information. Our unknowns we'll do in blue here. So we do not know this angle. Sometimes they refer to it as theta. Not this angle. You could call it beta. Or you could call them A and B, whatever you like. And we don't know this side. Let's say it's called side A in this case. Okay? Now, normally, to help with our sine and cosine law, if you notice, everything's in A, B, or C. So what we're going to do, it doesn't matter what they call a triangle, we're just going to rename the triangle. We're going to take away these values and just rename it. So let's just say that this is angle A, this is angle B, and this is angle C. We name everything with A, B, C. In order to get the sides then, from angle C, the opposite side of the triangle needs to be side C. That's the only restriction you have. You have to set it up that way. So in that case, if that's angle C, this becomes side C. If this is angle B, what is side B?
20.
Yeah. And if this is angle A, what is side A?
A. Wait.
The one that's unknown,
Oh,
right? Yeah, it's opposite of that. So now that we have that, it can sometimes be hard. What do I use, sine or cosine? Well,
that's when you use cosine, right? That one.
Yeah, you're right. This is when you use cosine. A good way to go about it, though, is to actually go, you know what? I don't know, so I'll try to set up both of them. Okay? Okay, so with that being said, like I said, we can try to figure it out. So what we'll do is we'll actually set up sine and cosine law. You already know we're going to use cosine law, and we'll talk about why it works. So we know the original one was sine A, right? So instead of writing in the A, I'm just going to write in the side, which is 50 degrees. The uppercase stills with the angles. And then side A, well, that one is unknown, is equal to angle B, sine, well, we don't have angle B, so we're just going to say sine B, right? We don't have the measurement of that angle. Divided by side B, well, that's 20. Is equal to sine C, well, we don't have angle C, so let's call it C, divided by side C, well, that's 30. Now, because I said this was a ratio, if you look carefully, there's 3 ratios altogether. In this case, the reason we can't use it is none of these 3 ratios are complete. There's a variable involved in each one. I can't do this unless I have one full set of ratio. So because I don't have a full set of ratio, I can't use sine law for this. I need to have a full set of ratio, which means then I must be able to use my cosine law by deduction. Well, remember I told you this is A, and the way we remembered our formula was c squared equals a squared plus b squared.
So would it be a squared equals b squared plus c squared?
Yes, exactly. Or, like I said, you know how we renamed the triangle the first time? You could really just rename it again and go, well, this is now C. Oh, why is that doing this so often? This is C, and this is C, right? And then we're left with this formula. We can do that if we like. It's going to go back to A. So let's just think of that way. Really, this is our unknown, our A. We're looking for the other side of this triangle. Okay, we're looking for the other side of this triangle, so we're going to use cosine to solve the other side of this triangle. And if we were looking for this angle, well, then we'd be looking for the angle part, or this angle, the angle part. But let's say we're looking for the side. Well, when we go to set up cosine, in this case, well, side C, or A in this case, we'll do it in red, is unknown. So we'll say a squared is equal to, and if this is C, well, C squared is 30, and B squared is 20, minus 2. A is, or sorry, B, which is 30 times 20, right? Cos, and C, well, that's just opposite of what we're looking at, so it's cos A in this case, cos 50 degrees. Okay, I'm going to quickly run through this one because it can be a little tricky. There is one part that we do tend to make mistakes. So let's solve for that A. Well, 30 times 30 is going to give us 900 plus 400 minus, this will be 600 times 2 is 1200, I believe. And then cos 50, all equal to A squared. This becomes 1300 minus 1200 cos 50. Now, this is a very common error.
You have the square root of A.
At the end, yeah, to get A by itself. A very common error is to take 13 and then subtract the 1200. But technically, this is 1200 times cos. So we actually have to get the cos 50 and then multiply it by the negative 1200. And then do this, okay? Because of BEDMAS. That's a very common error. You can't do that. You can't do it or you'll come up with something very, very different. So let's actually use our calculator here. 50 cos times negative 1200 is negative 771.3. So negative 771.3. And now it's 1300. Subtract 771.3 A squared. Okay?
But you can't have a negative number and a square root.
You're right, but 1300 is bigger than 771, right?
Oh.
So we take our 1300, subtract 771.3, we get positive 528.7, right? So we have 528.7 A squared. Well, to get rid of that squared, it needs to become square rooted on this side. So the distance of A is the square root of that, which in my calculator, I just hit square root for this one. 22.99. It is approximately 23, right?
Yeah.
22.99, really. Very close enough. So we've just used cosine to solve for side B, which is 23 in this case. Okay, so really, if you're unsure which one to use, try setting both up.
Because some involve, like when you do that, you have to cross multiply after that.
Yeah, and it completely depends on what's happening. But if you have a complete ratio, use sine law. It's usually easier. And if you can use sine law, you probably can't set up the cosine law to solve the question. In fact, you can't. Okay? So that's one way. If you're really unsure, set both up and look at them. Do I have enough information to solve one or the other?